to 10-4. This is actually going to kind of combine some ideas, but 10-4 is a big skill that you need to have as we move to 10-5. So I want to focus on differences between terms and factors. This is a big expression, the whole thing here, but two main things are being, in this case, subtracted. This and this. Okay, and our goal is going to be to factor it. So the factors of the first term, this circle, are x plus 7 and x. Okay, what are the factors of the second term? X plus 7 and 12. Now let me just take you back a second because you've done this before. You just may not have realized you were doing it. Before, when I gave you something like 8x plus 16, and I said, okay, here's your term, 8x, and your other term, 16. What is their common factor? You said 8, and then you did 8x divided by 8. That left you with x plus, and then you said, okay, well, 16 divided by 8, which is our factor, is 2. It was kind of the distributive property backwards. So you have done this, and what we're going to do here is the exact same idea. I have two factors in each of them. What is their common factor? Okay, in this case, the common factor is x plus 7. So I'm going to factor that out. Okay, so if I factor out the x plus 7 out of this term in this circle, what do I have left? Okay, and I'm going to put that in a parenthesis, just like here. Their common factor was 8 up here. When I divided 8x by 8, I was left with x. So when I divide this by x plus 7, I'm left with x. Minus, just like here, that plus was brought down, minus, okay, now let me go to this term. I divided it by x plus 7. What do I have left? 12. So this factor completely, you look for the common factor in each circle, and you factor that out, and that leaves you with x minus 12. In the same way we did here, we looked at the two terms, 8x and 16. Another way I could rewrite that for you is to say 8x plus 8 times 2. I'll put a little multiply sign in there, I guess. Times 2. And we factored out the 8, and we were left. So when we factored out the 8, kind of took that out, what were we left with? X plus 2. So we're going to continue that here in these examples. The only thing here is I do have a typo. If you printed the notes, that one shouldn't be there. So if you have the notes, don't cross that out. If you didn't, just don't use that. So again, I think it might help if some of you circle. This is a big expression. Two things are being added. This is being added with this. So what do the circles have in common? Okay, what they have in common is x minus 2. And when I factor that out of the first term, I'm left with x plus, because that's right here, and then the 6 is left from this term. And again, if you distributed this, you would get the same thing. So think of it, if I distributed the x minus 2 to the x, I would have x times x minus 2. And then I would distribute the x minus 2 to the 6, and I'd have this. It's just not all multiplied out. Now over here, be careful, because when we look at our circles again, this is being subtracted from this. You might say, well, this only has one factor. Well, don't forget, everything always has another factor of 1. Okay, so in this case, I'm going to factor out the 5x minus 8, and I'm left with 3x minus 1. The 3x, again, the minus, and then the 1. Just like when we did similar ideas, when you factored it out, you left a 1 so that if it distributed back. The other two, you can try, push pause and try, and come back and check the answer. All right, in this one, again, I'm just going to keep trying to do that to focus you. This whole thing is being subtracted from this whole thing. So what do they have in common? They both have 3r plus 5. Okay, when I factor that out, I'm left with 2a minus 7b. Now, a lot of you probably got to here, I'm hoping, but you may have missed that it does say up in the instructions to factor completely. And you have done part of the factoring, but look right here. This can be factored further. So I need to do that. Okay, so this is your final answer. That's factored completely. In the next set, we're doing some similar ideas. So again, you can push pause, give a try. I'll go through these first two with you just to help out because they did get a little trickier here. So again, it may help. I'm having this being subtracted from this. Okay, what do they have in common? They have 2r minus 9. I'm left with 6r minus 3. Now be careful. Every time you do this, then you have to say, okay, did I factor it completely? The 2r minus 9 I can't do anything with, but you can see the 6r minus 3 does have a GCF. It has a GCF of 3. So to factor it completely, I'm going to pull that GCF out. So 3 times 2r would be 6r. 3 times 1 would be. Now, you can write it this way. Normally, you're going to see me give the answer this way. I like to put the monomial in the front. But if you wrote it as the second line, that's okay too. Now, the second one seems crazy, but it's the same idea. This expression is being added with this expression. And just follow your same idea. Okay, what is in common? 2x minus 7. Okay, when I divide that out of this term, I'm left with x. Then there's the plus. Okay, I divided the 2x minus 7 out of here. I'm left with x plus 6. Okay, and I'm going to just look to keep simplifying. Okay. So I simplified everything in the parentheses the best I could. Now I'm going to double check. 2x minus 7. Can I break it into binomials? Does it have a GCF? No. What about this one? It can't be binomials, but it does have a GCF. So I'm going to pull the 2, and I'll be left with x plus 3. And again, I would normally write it as moving the monomial to the front. But I wanted to leave that in between step because I think some of you might not understand where the 2 came from. This 2x plus 6 turned into this. All right, try the other two on your own and then come back and check. Okay, I have this. I have this. What they have in common is x plus 3. That's the common factor. In the first term, if I take out the x plus 3, I'm left with x plus, because there's a plus right here. All right, over here I took out the x minus 5. I'm left with x plus 3. That gives me x plus 3 . Okay, now I'm going to double check. Does x plus 3 have a GCF? No. Does 2x plus 3 have a GCF? No. All right, I'm in good shape. Over here, we're going to do the same idea. This expression is being added with this expression. So they both have x plus 7 in common. from the first term, when I factor out the x plus 7, I'm left with x squared plus, again, that's coming from right here, plus 5x plus 6. It gives me x plus 7, x squared plus 5x plus 6. Okay, so I simplified as much as I could. But if you check, x squared plus 5x plus 6, can be factored into two binomials. So I do have a little bit farther to go with that. So this is your final answer. Okay, in the last two, I'm going to do those pretty quickly because it's a very similar idea, but you just want to be careful of the minus. These are the two expressions being factored. Maybe I'll leave the last one for you guys to do. So what do they have in common? 5y minus z. After I factor that out in the first term, I'm left with an x squared minus, again, the minus coming from over here in the middle, 12x minus 20. Now, some of you may have said before, why does she keep putting that second part in parentheses? It does matter here. So I'm going to go x squared. I'm going to distribute the minus sign. Again, we went over this in the beginning of the year. So that minus, it's like a minus 1. Minus 1 times 12, minus 1 times negative 20 makes that a positive 20. Now 5y minus z, there's no GCF. There's nothing I can do there. But I can factor this farther. So this is a very similar idea. The part I want you to be aware of is that minus. Okay, try the last question over here on your own, and I'll check that when you come into class, and we'll see how you do. Happy snow day!